Hello everyone. Today we'll see one of the data modeling technique, normalization. What is normalization and why do we need this normalization? We'll see in a minute. First of all, I feel we should be knowing what is normalization. Normalization is the process of decomposing and arranging data among the tables and ensuring that these tables talk among themselves using referential integrity. Normalization is ensuring that a certain table satisfies a particular certain number of functional dependencies on it. Normalization is especially used to remove redundancy from databases, as too much of redundancy leads to database inconsistency. As I have said, normalization is the process of arranging data in a database that includes creating tables and establishing relationships between the tables. As I have said, this process is used to help eliminate redundant data. We got 5 normalization forms. First normalization form actually eliminates the repeating groups. Second normalization form eliminates redundant data. And third normalization form eliminates columns that are not dependent on the key. And in fourth normalization form, it actually isolates independent multiple relationships. Fifth normalization form isolates semantically related multiple relationships. We'll see in more detail about these normalization forms in a bit, but in this particular video, I'm only going to talk about first 3 normalization forms, because disregarding the 4th and 5th normalization forms in the database modeling technique may lead a less perfect database but doesn't affect the functionality of the database. In this particular video, I certainly can talk about functional dependencies and differential integrity, but I don't want to make it complex. I want to keep it as simple as I can, and I just want to focus only on the process of normalization. So we'll go and see them in a more deeper way. So if we come to first normalization form, in which we'll remove the repeating group, ensuring certain conditions are met with tables. We eliminate repeating groups in individual tables, create separate tables for each set of related data, identify each set of related data with primary key. We do not use multiple fields in a single table to store similar data. If we come to second normalization form, the second normalization form ensures each attribute describes the entity. As I have said, it especially focuses on removing redundant data. We create separate tables for a set of values that apply to multiple records, relate these tables with a foreign key. Records should not be dependent on anything other than a table's primary key, including a compound key. Third normalization form checks for transitive dependencies. In this, we eliminate attributes that are not dependent on the key. Values that are not part of the record's key do not belong in the table. Actually, we create a separate table for them. In general, if the contents of a group of fields apply to more than a single record, put these fields in a separate table. Other normalization, as I've said, 4th and 5th normalization forms do exist. 4th normalization form, which is more near to Boyce code normalization form, but also disregarding or not considering these in data modeling technique may lead in a less perfect database, but doesn't affect the functionality of the actual database. So we'll see these first 3 normalization forms in deeper with an example. You can see there's an unnormalized table having attributes student, advisor, advisor room, class 1, class 2, class 3. You can see that in the unnormalized table, class 1, class 2, class 3 all belong to the same type. Actually, they belong to the similar type. They are of same group. So in the first normalization form, we'll ensure that we remove repeating groups. So in first normalized table, you can see down below there, we only have 4 attributes, naming student, advisor, advisor room, and class. In this, student 1022 having advisor, having advisor Jonas, advisor room 412 goes to classes 101, 07, 14301 and 15902. And the student 4123 having advisor Smith and advisor room 216 go to classes 20101 and 21102 and 21401. Thus, we remove these repeating groups and we form a new table by using first normalization form. Thus, we say that table is in first normalized form. If we come to second normalization, we see that in first normalized table we are repeating student, advisor and advisor room for every tuple. So there is too much of redundant data, so we'll ensure that these redundant data gets removed in the second normalization form. So we created two tables, students and registration. In the student table we'll only have student, advisor and advisor room, and we created another table, registration, in which we will have attribute student and advisor class. So much of the redundant data gets eliminated in the second normalization form itself. If we go to third normalization form, in which we'll eliminate the keys which are not part of the which are not dependent on the key, we see that in the second normalized form, table students containing an attribute advisor room which is independent of the key student. So we eliminate that from that table and we create another table called faculty, in which we'll have attributes name, room and department number. Now the student table contains only student and the student and advisor. Summary: as I have said, normalization is a process of organizing data in a database that includes establishing relations between the tables. While ensure some or the other way, we eliminate the redundancy in the tables. Disregarding fourth and fifth doesn't affect the functionality of the database. Hope you guys liked the video. Please do subscribe down below. Thank you.